Okay, so let's consider the double angle formula for cosine. I know that cosine of 2 theta is cosine squared theta minus sine squared theta. But I also know from my main Pythagorean identity that cosine squared theta plus sine squared theta is equal to 1. So what that means is that cosine squared theta is 1 minus sine squared theta if I subtract sine squared from both sides. So let's use that fact. Let's use that fact right here. So I can rewrite this as 1 minus sine squared theta, from which I'm subtracting sine squared theta. So this becomes 1 minus 2 sine squared thetas. Or I could replace sine squared. So once again, cosine of 2 theta is cosine squared theta minus sine squared theta. And I know that cosine squared theta plus sine squared theta is equal to 1, meaning that sine squared theta is equivalent to 1 minus cosine squared theta if I subtract cosine squared from both sides. So I can rewrite this as cosine squared theta minus the quantity, because I have to distribute that negative, 1 minus cosine squared theta, and quantity. So this gives me cosine squared theta minus 1 plus cosine squared theta. That's a terrible cosine squared theta. Let me rewrite that better. Cosine squared theta. So that is, I have 2 cosine squared thetas minus 1. Okay. So let's recap the double angle identities for cosine. So double angle identities for cosine. Angle identities. Identities for cosine. It's a long title. So we have the main identity is cosine of 2 theta is cosine squared theta minus sine squared theta. However, we just showed that cosine of 2 theta can also be written as 1 minus 2 sine squared theta. And then we showed after that cosine of 2 theta can be written as 2 cosine squared theta minus 1. So we have 3 double angle identities for cosine. So let's consider the first one, the first alternate identity, namely 1 minus 2 sine squared theta is equal to cosine of 2 theta. And let's subtract 1 from both sides, so I get negative 2 sine squared theta is equal to negative 1 plus cosine of 2 theta. And now let's divide by negative 2. So I get that sine squared of theta is 1/2 the quantity, if I change the signs, 1 minus cosine of 2 theta. So I divided by a negative 2 and changed the signs. Alternately, I could start with the third identity, namely 2 cosine squared theta minus 1 is equal to cosine of 2 theta. So in this case, I'm going to add 1 to both sides, so 2 cosine squared theta will be equal to 1 plus cosine of 2 theta. And finally, I'll divide by 2. So I'll get that cosine squared theta will be 1/2 the quantity, 1 plus cosine of 2 theta. Finally, I note that tangent squared theta is going to be sine squared theta divided by cosine squared theta so that's going to be, let me go down here. So sine squared theta we found to be 1/2 the quantity, 1 minus cosine of 2 theta, whereas cosine squared theta we found to be 1/2 the quantity, 1 plus cosine of 2 theta. So given that these 1/2s reduce, we arrive at tangent squared theta is equal to 1 minus cosine of 2 theta divided by 1 plus cosine of 2 theta. Let's also note, given these, so which one did I do first? I did sine. So we have sine squared theta is positive 1/2 times the quantity 1 minus cosine of 2 theta, which means that sine of theta will be plus or minus the square root of 1/2 the quantity 1 minus cosine 2 theta. Maybe I should have left a space there, but hopefully you guys can see that. Similarly, we have cosine squared theta was given as 1/2 the quantity 1 plus cosine 2 theta, which means that cosine of theta will be plus or minus the square root of 1/2 the quantity 1 plus cosine 2 theta. And I'll show you where the plus or minus comes into play in a moment later on when we do examples. Oh boy, square roots just don't want to work for me. Okay, finally we had that tangent squared theta was the quotient 1 minus cosine 2 theta over 1 plus cosine 2 theta. Hence, tangent of theta is plus or minus the square root of 1 minus cosine 2 theta divided by 1 plus cosine 2 theta. These are the half angle formulas, so let me state them formally. Or actually, before I do that, let me state where before I took the square root. Yeah, let's state the power reduction formulas. So power reduction formulas. And they are all the squared guys, namely sine squared theta is 1/2 the quantity 1 minus cosine 2 theta. Cosine squared theta is 1/2 the quantity 1 plus cosine 2 theta. And then tangent squared theta is 1 minus cosine 2 theta divided by 1 plus cosine 2 theta. So these are called the power reduction formulas. And now I will do the half angle formulas, which are derived from the power reduction formulas, so half angle formulas. Okay, so we have that sine of theta is plus or minus the square root of 1/2 the quantity 1 minus cosine 2 theta. Basically, I'm just taking the square root of the power reduction formula. Similarly, cosine of theta is plus or minus the square root of 1/2 the quantity 1 plus cosine 2 theta. And finally, tangent of theta is plus or minus the square root of 1 minus cosine 2 theta divided by 1 plus cosine 2 theta. Okay, so I'm just going to continue on. So for example, express cosine squared theta times sine squared theta as a linear expression, meaning no powers more than 1 in cosine. Okay. So cosine squared theta times sine squared theta. Well, that's going to be cosine squared is 1/2 the quantity 1 plus cosine 2 theta. And sine squared theta is 1/2 the quantity 1 minus cosine 2 theta. So looking just at the coefficients 1/2 and 1/2, their product is 1/4. And then looking at 1 plus cosine 2 theta and 1 minus cosine 2 theta, I notice that's a difference of squares, namely 1 squared minus cosine squared of 2 theta. So what this gives me then is 1/4 the quantity 1 minus cosine squared of 2 theta. So let me go ahead and distribute the 1/4 inside. So this becomes 1/4 minus 1/4 times cosine squared of 2 theta. But that's not linear because the power is still 2. So I need to use the power reduction formula again. So this will be 1/4 minus 1/4 cosine squared is 1/2 the quantity 1 plus cosine of twice the angle. So that's going to be 4 theta, because 2 times 2 is 4. So this gives me 1/4 minus 1/8 the quantity 1 plus cosine of 4 theta, and I can go ahead and distribute. So what I get then is 1/4 minus 1/8 minus 1/8 cosine of 4 theta. Combining the first two terms, 1/4 is 2/8, so 2/8 minus 1/8 gives me 1/8 minus 1/8 the quantity cosine of 4 theta. Notice that the exponent on cosine is now 1. So check mark, so there we are. We've done it. Okay, I'm going to continue on. So for example, let's evaluate the following. So number 1, what about sine of 7 pi over 8? So this is going to be a half angle formula. So let's recall. sine of theta was plus or minus the square root of 1/2 the quantity 1 minus cosine of 2 theta. Now the plus or minus has to do with which quadrant the angle is in. So we have sine of 7 pi over 8. So 7 pi over 8 is close to 8 pi over 8, so that's in quadrant 2. So I claim that this will be plus or minus square root of 1/2 the quantity, 1 minus cosine of twice the angle. So actually no, that's okay. I'll keep that parenthetical. So 2 times the angle, and the angle in this case is 7 pi over 8. And since my angle, 7 pi over 8, 7 pi over 8 is in quadrant 2, I know that I'm going to choose for sine, which is a y-coordinate, plus. Okay, so what do we get? We get the positive square root of 1/2 the quantity, 1 minus cosine of 7 pi over 4, because 2 over 8 reduces to 1 over 4. Okay, moving to the next page. Now we can plug and chug. So we have that sine of 7 pi over 8. Actually, do you know what? That's going to drive me crazy with that circle around there. 7 pi over 8 will be equals to quantity 1/2. 1 minus, well, what is cosine of 7 pi over 4? Well, that's the x-coordinate value at the 45-degree reference angle in quadrant 4. So that's going to be root 2 over 2. So this becomes the square root of 1/2 minus the square root of 2 over 4, if I distribute, which becomes the square root of 2 minus root 2 all over 4. But of course the square root of 4 is 2, so I can write this as a square root of 2 minus the square root of 2 all over 2, because the square root of 4 is 2. Okay, oh my goodness, that was a long one. Let's do another long one, shall we? Okay, so number 2. Let's evaluate cosine of pi over 12, which is actually 15 degrees. Okay, let me do this in green to change it up. So cosine of pi over 12. Well, maybe I should recall first. What was the half angle formula for cosine? Let's recall. That cosine of theta was plus or minus the square root of 1/2 the quantity 1 plus cosine of 2 theta. And the plus or minus depends on which quadrant our angle is in. So for us, cosine of pi over 12 will be plus or minus the square root of 1/2 the quantity 1 plus cosine of twice the angle. The angle here is pi over 12. Okay. Oh no, not again. Close enough. Okay. So let's note that pi over 12 is definitely in quadrant 1, so cosine is positive. So this will be the positive square root of 1/2 the quantity 1 plus cosine of pi over 6, because 2 over 12 reduces to pi over 6. So this becomes the square root of 1/2 the quantity 1 plus the square root of 3 over 2. Yeah, okay. Maybe I should have done that, but that's okay. Let's distribute the 1/2 inside. So this becomes 1/2 plus the square root of 3 over 4. So getting a common denominator, this will be the square root of 2 plus the square root of 3 all over 4. But in the denominator, the square root of 4, of course, is 2. So I have the square root of 2 plus the square root of 3 all over 2. Okay, so before I move on, let's recall. So in a 1575, actually, in a 1575-90 right triangle, the sides were in a ratio, of square root of 6 minus the square root of 2 all over 4 to the square root of 6 plus the square root of 2 all over 4 to 1. Okay, well, pi over 12 is 15 degrees. Cosine is going to be the longer side, so cosine should be this middle value. What? Is that the same thing? Well, let's see. Let's consider. Is the square root of 2 plus the square root of 3 all over 2? Is that equal to question mark? Square root of 6 plus the square root of 2 all over 4? Well, let's see. What I'm going to do is I'm going to try and get rid of that external. Actually, let me copy and paste and then do that. So, copy, paste. I'm going to square both sides first of all. So let's square both sides so I don't have a square root inside a square root. So on the left-hand side, what I get is 2 plus the square root of 3 all over 4, because I'm squaring both the top and the bottom. And I'm asking, is that equal to? So the square of the right-hand side, when I square the numerator, I get the first term squared plus twice the product of the first and the second. So underneath the radical, 6 times 2 is 12, plus the square of the second term all over the square of the denominator, which is 16. So I'm just going to continue on the right-hand side for now. I know that 6 plus 2 is 8, so is 8 plus 2 times the square root of 4 times 3, because that's what 12 is, all over 16. Well, is that equal to question mark? Let's move down. Is that equal to question mark? And let me copy and paste this down here. So that's 8 plus square root of 4 is 2. So if I bring that out, 2 times 2 is 4, root 3, all over 16. Well, let's see. So what's common? It looks like 4 is common. So I'm going to factor a 4 from the numerator, which leaves me with 2 plus the square root of 3. All over, I'm going to factor a 4 from the denominator. So that leaves me with 4 times 4. So once I reduce these 4s, I do indeed very much get what's on the left-hand side. I get 2 plus root 3 all over 4. So I wasn't lying to you early on. That's good. So they are indeed the same value. Okay. Let's do another example, maybe with sine. Yeah, let's do sine. How about sine of 23 pi over 12, just to make it miserable? So let's see, cosine was number 2. Let's have sine be number 3. So number 3. So sine of 23 pi over 12. Okay, so let's recall, maybe in pink. We know that sine of an angle theta is plus or minus the square root of 1/2 the quantity, 1 minus cosine of twice theta. Okay, so we have sine of 23 pi over 12. So I claim that that will be plus or minus the square root of 1/2 the quantity, 1 minus cosine of 2 times the angle 23 pi over 12. Okay, so 23 pi over 12, where is that? Well, do you agree 23 pi over 12 is 1 pi over 12 shy of 2 pi? So this must be in quadrant 4. So the value for the y-coordinate or sine is actually negative in quadrant 4. So this will be negative the square root of 1/2 the quantity, 1 minus cosine of, well, this is going to reduce to 23 pi over 6, because 12 over 2 over 12 rather. 23 pi over 6, that's not on the unit circle, because 6 goes into 23 3 times, 18, with 5 left over. So that is going to be, what is that going to be then? Well, let me break it up. So 1 minus cosine of, I claim that this is 11 pi over 6 plus 12 pi over 6, and 12 pi over 6, of course, is 2 pi, right? So I can ignore this guy right here. Ignore. Because full circle. Okay. So I can rewrite this as negative the square root of 1/2 the quantity, 1 minus cosine of 11 pi over 6, which is the x-coordinate in quadrant 4 of the 30-degree reference angle. So that's going to be minus the square root of 1/2 the quantity, 1 minus, so that's going to be square root of 3 over 2. So let's distribute the 1/2 inside. So this becomes the square root of 1/2 minus the square root of 3 over 4, getting a common denominator. This becomes minus the square root of 2 minus the square root of 3 all over 4. But of course, the square root of 4 is 2. So this is minus the square root of 2 minus the square root of 3 all over 2. But once again, let's recall. The ratio was root 6 minus root 2 all over 4 to root 6 plus root 2 all over 4 to 1. So in this case, I'm looking for sine. Now sine, of course, is going to be the smaller coordinate if I'm at 15 degrees. So I'm wondering, Is this equivalent to this, question mark? Well, let's find out. So let's consider. Consider so let's say in absolute value, by the way. So I'm going to consider the absolute value 2 minus the square root of 3, because it's going to be the same save for sign, all over 2. Is that equal to question mark? Root 6 minus root 2 all over 4. Okay, so once again, what I'm going to do is let's square both sides. So I can get rid of that squared on the left. So on the left, what I get then is 2 minus the square root of 3 all over 4. Is that equal to question mark? So squaring the right-hand side will be first guy squared minus twice the product of the first and the second plus the second guy squared all over 4 squared, or 16. Now I'm just going to continue down the right-hand side. So this becomes, is this equal to question mark? 8 minus 2 times the square root of 4 times 3 all over 16. So is that equal to 8 minus, when I factor out the square root of 4, that becomes 2 times 2 is 4. Square root of 3 all over 16. So going to the next page. So is this equal to, let's factor out a 4 in the numerator. In a different color, let's factor it out in green. So that'll be 2 minus the square root of 3 all over, let's factor out a 4 in the denominator. 4 times 4. The 4's reduce. And I'm left with the fact that yes, this is indeed equal to 2 minus the square root of 3 all over 4, check mark. So we got it right as well. I hope this is making sense. I think I'm going to just continue on. This will be a long video, but you know what? So be it. So for example, let's verify the following identities. So let's verify the following identities. So number 1, let's say we have quantity sine squared theta minus 1 all squared is equal to sine to the 4th of theta plus cosine of 2 theta. Okay, so I'm going to start on the left. Doesn't really matter. In this case, they're both equally ugly. But since I've got something squared here, let's go ahead and distribute. So the expansion of the binomial will be the square of sine squared, that is sine to the 4th theta, minus twice the product of sine squared and 1, plus 1 squared. Okay, well remember, we had that cosine of 2 theta was 1 minus 2 sine squared theta. That was one of my double angle formulas for cosine. Let me move this back up. Okay, it's not letting me. No, it's not letting me. Okay. Shoot. Maybe? Okay, there we go. Okay, so I can rewrite. Let me rewrite it in order so you see what I'm talking about. So sine squared plus 1 minus 2 sine squared theta So now it's in the correct order. So I can write this as sine squared theta plus what amounts to cosine of 2 theta. And voila, we have shown that it is indeed true. Okay, good. We got the right-hand side. Okay, so number 2. Let's do another one. Let's say we have cosecant squared of theta is equal to cosine of 2 theta divided by sine squared theta plus 2. So it should be clear that the right-hand side here is the ugly side. So I'm going to start there. So we have cosine of 2 theta divided by sine squared theta plus 2. Okay, so I'm going to rewrite this. Let's color code a bit. So I'm going to rewrite cosine of 2 theta divided by sine squared theta plus, if I multiply 2 top and bottom by sine squared theta, this will be 2 sine squared theta divided by sine squared theta. So now I have a common denominator. So I can write this as cosine of 2 theta plus 2 sine squared theta all over sine squared theta. And now let's rewrite cosine of 2 theta as his main identity, which is cosine squared theta minus sine squared theta. Then I have plus 2 sine squared thetas all over sine squared theta. So how many sine squared thetas do I have? So I have negative 1 of them here, positive 2 of them here. So what it looks like is I have cosine squared theta plus a single 1 sine squared theta all over sine squared theta. Now, of course, what I have in the numerator is my main Pythagorean identity. I know that cosine squared theta plus sine squared theta is equal to 1. So I can replace the whole numerator with 1. So this becomes 1 over sine squared theta. So since s's and c's go together, I claim that this is cosecant squared theta, which is exactly the left-hand side. Check mark. I've established the identity or verified it. So let's see, how much room do I have? I have enough room. I guess I can always go to the next page. Okay, so number 3, maybe I'll start here. Let's verify that 2 cotangent of 2 theta is equal to cotangent of theta minus tangent of theta. So I'm going to start on the left, actually. So 2 cotangent of 2 theta, I claim, is going to be 2 divided by tangent of 2 theta, because tangent and cotangent are reciprocal identities. So this will be 2 divided by, what is tangent of 2 theta? Well, let me color code him to purple. Tangent of 2 theta was 2 tangent theta divided by the quantity 1 minus tangent squared theta. So this is the whole denominator. So now I can invert and multiply. Let me see if I can save myself some space here. So this will be equal to 2 times the reciprocal, namely 1 minus tangent squared theta divided by 2 tangent theta. So the 2's reduce. So what I'm left with then is going to be 1 minus tangent squared theta over tangent theta Okay. I guess I didn't really have enough room here, did I? Okay, so maybe I should just move this to the next page. Try and align it a bit better. So still doesn't look like it's aligned very well. Okay, so tangent theta, the denominator, is common to both terms. So I can write this as 1 over tangent of theta minus tangent squared theta over tangent of theta. But I know that 1 over tangent is cotangent theta minus, and I know that one of the tangents reduces here, and what I'm left with is a single tangent. And that is indeed what I wanted to show. That is the right-hand side, so check mark. I have established or verified the identity.